All right, lesson 1B starts out talking about concavity and inflection points. And so you may remember talking about concavity from previous math classes. And so we have, looking at the picture here, we have concave up when it looks like it's part of a smiley face. And we have concave down when it looks like it's part of a frowny face. All right, so concavity will change at these points. They call inflection points. And so let's start out kind of talking about them. So an inflection point is where a curve changes from concave up to concave down or vice versa. To actually find where that point is at, you're going to need calculus in order to do it. But we're going to talk about in just a few minutes here a little bit on how we can estimate that point. All right, so in example 5 here, it says use the graph of g of x shown at the right to determine intervals of concavity and to state the points of inflection. So first let's go through and find our points of inflection. Remember we just said that that's where concavity is going to change. And so it's going to be a point that is somewhere between a minimum and a maximum, or a maximum and a minimum. So when I look at my graph here, first thing I notice is I have a minimum right here, down here at -3, -8. And I have a maximum up here at 2, 2. So I know somewhere in between those two is going to be a point of inflection. And so the only other point they gave us is somewhat in the middle here of the two, is the point at -0.5, -3. And so that right there is going to be one of my points of inflection. Then I notice, again, I still have this maximum, little maximum here at 2, 2, but I also have a minimum down here at 4, 0. Which means in between those 2 points, I'm going to have a point of inflection. And so in between those 2 points is that point 3, 1, which is approximately halfway between them. And so therefore, this here, the point 3, 1, is going to be my point of inflection. So we already know our points of inflection are going to be at -0.5, -3, and at 3, 1. Now, when we look at our graph, let's look at it going from left to right, just like we always read a graph. And so I can see right here in this first part that I'm looking at part of a smiley face. That little part there is opening upwards, so this is concave up. It starts being concave up on the far left at -infinity. And it's going to stop being concave up at that point of inflection where it's going to change there from concave up to concave down. So at -0.5. Remember, we always label by the x values. All right, after that point of inflection there, at the -0.5, when we just look at this next piece, we're looking at part of a frowny face. And so that part of that frowny face we know is concave down. And so it starts being concave down at that -0.5. And it stops at that next point of inflection, which is when x is 3. And then after that point of inflection there, we can see it's changing again. And this, again, now it's going to be part of a smiley face. And so we know we are concave up. And that's going to be from that point of inflection at 3. And it just keeps being concave up. It never changes again. So it keeps going to the right to positive infinity. Then for example 6, it says the function given there is shown at the right. This one's going to kind of walk us through how to find a good estimate of that point of inflection. Is it going to be exact? Not every time, but it's going to be a good estimate of it. To get exact, we'd have to use calculus. All right, so A says let's find the average between the high point and the low point to determine an approximate value for the x-coordinate of the point of inflection. So we're going to look at our high point and we're going to look at our low point and we're going to use those x values to find an average of them, and that's going to give me approximately the x-coordinate of my point of inflection. So for A, I'm going to find that x value by taking the x of the maximum, so -2, plus the x of the minimum, 1, and find their average. I'm going to add it together and divide by 2. And so it tells me that my x-coordinate is going to be -1/2. B says, now that we have an x-coordinate and we have an equation, we're going to go find that y value. And we do that just by plugging in our x into our equation. So for our y value, we're going to go take that equation and plug that -1/2 into it. So when we do that, we'll get 5/2. And so we know that our point of inflection is going to be at -1/2, 5/2. Now, if you wanted to use decimals, these are nice, neat decimal places, you're more than welcome to, okay? You don't have to keep it as a fraction, but we don't want to round it. We don't want to estimate it. So if they're not nice decimals that end, then go ahead and change them to fractions. All right, and then C. C wants us, now that we know that point of inflection, and look at it, does that point of inflection right there in between the maximum and the minimums, does it look like it's approximately -1/2 and 5/2, which is 2.5? It does look like it. So we didn't do too bad. And now it wants us to use that point of inflection to state the intervals where the function is concave up and concave down. So I'm going to go ahead and just write concave up and concave down. So all I have to do is go back and answer it. All right, so I'm going to start on the left part of my graph again. And so I can see right here that this is part of a frowning face. And so it's opening downwards, which means it's concave down. So it starts at the far left, which is -infinity, all the way into that x of the point of inflection, which was -1/2. And then after that point of inflection, we can see that it changes concavity, and it's now part of that smiley face, so it's concave up. So that started at -1/2, and it never changes back to concave down, so it keeps going to the right to infinity. All right, then our intercepts. X-intercepts. So remember, x-intercepts are where it's going to cross the x-axis. It's where our y value is 0. They're also called solutions, zeros, and roots. Just another word for them. All right, when we write it as an ordered pair, we're going to write it as x, 0. Our y-intercepts are going to be where it crosses the y-axis. It's where x is 0, and we write it as 0, the y value. So example 7, sit in the graph below, name the intercepts. And so we can see here that we have 3 x-intercepts. So my x-intercepts are at -3, 0, 1, 0, and 4, 0. And then my y-intercept, I can see it just crosses the y-axis in one spot right there, which is at 0, -3. Now for our equation here in example 8, it says find the intercepts of the function algebraically given the equation there. So it doesn't want us to plug it in our y equals and look at our graph. It wants us to do this algebraically. So I'm going to start out with my x-intercept. And so I know with my x-intercept, I'm going to plug in y as 0. Well, remember, y is the same thing as f of x. So we have 0 equals x cubed minus 3x squared minus 4x plus 12. Now remember, anytime you have an equation where you have more than one form of the x, so like x cubed and x squared or x squared and x, they're not like terms, but they both have more than one of them that's got the variable, then you're going to have to factor in order to solve it. And so we have 4 terms here, and so we're going to factor by grouping. And so I'm going to group the first 2 and group the second 2 together. And then we just grade as common factor. So x cubed and 3x squared, I can take out an x squared. I'm going to divide x squared out of both of them. That leaves me with x minus 3. For the negative 4x plus 12, I'm going to common factor out that -4. And when I divide both of those by -4, I get x minus 3. And then technically, we're just going to grade as common factor again. We've got these 2 terms here, and they both have an x minus 3 in common. So we're going to take out an x minus 3 times, when I take it out of each term, I'm left with x squared minus 4. Now we're still not done factoring because the x squared minus 4 is a difference of squares. And so I'm going to bring down my x minus 3. And remember, with difference of squares, you're going to have 2 parentheses. One's going to have a plus, one's going to have a minus. And you take the square roots. The square root of x squared is x. Square root of 4 is 2. And now everything is factored completely. But don't forget, we still have this 0 equals there on the left. And so now we're going to set each one of our factors individually equal to 0 and solve. So x minus 3 equals 0, which gives us x equals 3. X plus 2 will equal 0, which will give us x equals -2. and x minus 2 equals 0, which will give us x equals 2. And if we needed to write these as an ordered pair, remember x will get the number and the y value is 0 for each of those. Then we need to still do the y-intercept. And for the y-intercept, don't forget that means that x is 0. And so I'm just going to plug in x is 0. Anything with a 0 in it will cancel. And so I just get that the y-intercept is at 12. And as an ordered pair, that would be 0, 12. Applications. So our first one says Tina is a sales clerk at Electronics Depot who earns $325 base pay plus $18 for each item sold. Express her gross salary G as a function of the number of X items sold. Find her gross pay if she sells 24 items. So we're after her gross pay in terms of the items sold. So G of X equals, she's going to make that $325 base pay, which means it doesn't matter how many items she sells, she's still going to get at least that amount. Plus, it says $18 for each item sold. For each is one of those keywords for multiply, and the item sold is X. Then it said to find her gross pay when she sells 24 items, so that just means our X is going to become a 24. And so that will give us $757. Don't forget to label it. Example 10. If your pre-cal book is dropped from a height of 45 feet on the planet Newton, its height in feet after t seconds is approximately h of t equals 45 minus 14t squared. How long does it take for the book to hit the surface of the planet? All right, so they gave us an equation there. Make sure you know what your variables represent. H is the height in feet. T is the time in seconds. And wants to know how long, so that means we're looking for T, so I need to know what is H. Make sure you read the rest of the question, though, because it does talk about that the pre-cal book's being dropped from a height of 45 feet. So if you just think about height, and you see that the height of 45, you're liable to try to plug it in. But also be careful, because that 45 is also a number that's in the equation, and so that's where they got that number from. So it's just really extra information there we didn't have to solve the problem, because they gave it to us in the equation. But it does say, how long does it take for the book to hit the surface of the planet? So what would be the height when it hits the surface of the planet? That would be a height of 0. So we're going to plug 0 in for H. And we're going to solve for T. So I'm going to subtract my 45. I'm going to divide by the negative 14. And so T squared equals 45 over 14. As a decimal, it's not pretty, so I just went ahead and left it as a fraction, because we don't want to round into the end. And then to get rid of the square, we're going to take the square root. So we get T equals plus or minus, and then the square root of 45 over 14. Well, we're almost to our answer here, so I'm going to go ahead and round it to 3 decimal places. So 1.793. But you got to think now, so we solved the equation when it was equal to 0, but have we solved the problem? Well, the problem wants to know how long. So can T be, T which is time, can it be positive or negative? Time can't be negative. So although the plus or minus was for our equation, we know for this problem we're only going to use the positive answer. And then make sure your label time is in seconds. All right, in example 11, it says use the graphs of functions f of x and g of x shown at the right to answer the following. And so just be careful, make sure you don't get the lines all mixed up, that you can follow f of x and you can follow g of x when you're answering the questions here. So it says find the domain of each function, f of x. So this is our f of x graph, and so I can see it does keep going to the left. It keeps going, see, I went to the wrong one. It keeps going to the right. I don't see any holes, jumps, gaps, asymptotes, anything like that in between the two, so it's continuous. So our domain is negative infinity to infinity. For g of x, we see it keeps going to the left, it keeps going to the right. Again, there's no holes, no jumps, no gaps, no asymptotes, so therefore it's negative infinity to infinity for its domain. B says the values of x such that f of x equals 0. So we want to go to our f of x graph, and we're looking for where f of x equals 0. Well, remember, f of x is the same thing as y, so y equals 0 on the x-axis. So I'm just looking for where f of x crosses the x-axis. And so I can see that it happens there at negative 4, and it just wanted the x values, so negative 4. Here at 2. And then I can't really see it, but I know if it's coming back down, it's going to cross again somewhere over here. So I'm going to say at 15. All right, then we're looking for where g of x is going to equal 0. So this time we're doing the same thing. We're going to use our g of x graph, and we're looking for where it's equal to 0, which means on the x-axis. So I can see there at negative 2, at 5, and at 7. All right, now if I go on to the next slide, you're not going to be able to see my graph. So I'm just going to answer them up here beside the graph and just label them C, D, E, F, G, H, I, J, K, L as I'm doing it. All right, so C. C wants us to find, it says the x values which f of x equals g of x. If I'm looking for where they're equal, I'm looking for where they intersect. And so I just want the x values where they intersect. So it's going to be at x equals, I can see right here when x is negative 3, right there when x is positive 3, and right there when x is 9. So we said negative 3, positive 3, and 9. D wants the x values for which f of x is greater than g of x. So that means where is f of x going to be drawn above g of x? Now when we're looking at the inequalities, we're going to be talking about intervals. So f of x is greater than g of x. So f of x is on top, so I can see that's right here. Then it's going to dip below it. It's going to come back up here, above it. And then it's going to be below it again. So I can see that's from negative infinity to negative 3. It's going to be from 3 to 9. And that's it. E says for the x values, which f of x is less than g of x. So now I'm looking for where f of x is below g of x. So I can see that's right here. And then it's also all the way here. So for where f of x is below g of x. So that's from negative 3 to 3. And then from 9 to infinity. All right, F says for which x values which g of x is greater than 0. So g of x is greater than 0. So that means where my g function is above the x-axis. So right there and right here. So from negative 2 to 5. And then from, negative 2 to 5, and then 7 to infinity. G says the values of x such that f of x is less than 0. So I'm looking for where f of x is below the x-axis. So from -4 to 2, and then be careful because remember this one kept going, and we said that was at 15 to infinity. So we said -4 to 2, and then said 15 to infinity. Yes. All right, H says the values of x such that f of x is increasing. So let me erase some of these things here. And I'm going to go ahead and erase these. So make sure you had them. If not, back up the video a little bit there so you make sure you got them. All right, we're on H. So H wants where f of x is increasing. All right, so f of x, I can see here I'm decreasing, 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 and somewhere in here I'm going to start increasing to there. So it looks like, what, -1 to 3.5? So -1 to 3.5. And remember, we said we're going to use closed intervals on increasing, decreasing, and constant. Let's see, and then I keep going. That's constant, and then it's decreasing. So that's the only place f of x would be increasing. All right, so that's H. Then I says where g of x is constant. And so we're going to look at g of x. It's increasing, increasing, decreasing, increasing. It's not constant, so none. J says where g of x is decreasing. All right, so g of x is decreasing. So I can see in here we're increasing, then we're increasing at a different rate. Then here we start decreasing, so from 3 to 6, and then we're increasing again. So only from 3 to 6. And remember we said we're going to use closed intervals for increasing, decreasing, and constant. Okay, then K. K says that values for which f of x is greater than 0. So f of x is greater than 0, so I'm looking for where f of x is above the x-axis. And so I can see here from -infinity to -4. And then from 2 to what I called 15 over there. So we said -infinity to -4 and 2 to 15. And then, okay, L says the x values to which f of x decreases. So let me erase some of my marks here. So I'm looking for where f of x is decreasing. So I can see it's decreasing right here. So from -infinity to -1. Remember, we're using closed intervals, but infinities will always have parentheses. And then we can see it's decreasing again here from 6 to positive infinity. All right, guys, so that is the end of lesson 1.